Welcome to 7.1. Here we're going to look at some inverse trig functions. Specifically, we're going to focus on just sine and cosine. And what we want to make sure that you remember is that sine and cosine have very limited outputs when we talk about their inverse functions. Because what do you remember about inverse functions? You remember they have to be 1 to 1. So let's remind you what y equals sine x looks like. You just were doing it. It's the real reason why they do it. But here's sine x. And that thing is definitely not a 1 to 1 function. And so it can't have an inverse. Well, what do we do when a function is periodic like this and can't have an inverse? Well, we cut it. And where we cut it is we cut it from pi over 2. Well, from, apologize, let me write that again. From, get my right bearings here. I was going to draw negative pi over 2 somewhere different. From negative pi over 2 to pi over 2. Because that's what spans from negative 1 to 1 and just does it one time. So sine's cut in that way. So essentially, let me get an pixel eraser here. So this is gone, right? And we're only looking at the sine function from minus pi over 2 to pi over 2. And why? You can visually see because it spans the whole range from negative 1 to 1. You know what an inverse function does. It's got to take negative 1 to 1 and map it back into the angles. And so when we talk about y equals sine inverse of x, right, that function, or if you remember the same thing as arc sine of x, right, both of those are inverse functions. The output for these is the domain certainly is from minus 1 to 1. That is obvious, right? That we can't, sine's not going to produce a value outside of negative 1 to 1. The range, though, the range for sine inverse is from minus pi over 2 to pi over 2. Similarly, if we were to do the same thing for cosine, remember, if you have cosine inverse of x, or arc cosine of x. Both of those are the same thing as you remember in your previous class. Your domain is still negative 1 to 1 because cosine never went outside of that. But the range, well, remember what cosine looks like. Cosine starts high and drops and comes back up, and so we can't go from the same minus pi over 2 to pi over 2 because the function's not 1 to 1 over there. And so we can't do that. And so we take it from 0 to pi. Right? So 0 to pi. So the range is from 0 to pi so that we get the same negative 1 to 1 type of input in there. So there's very real reasons why we picked that. It's the first continuous region right around 0 in which we span the entire range for the corresponding function. So you know inverse functions map us back. So when we do something like these aren't the first questions. The first question is something like very simple, sine inverse of negative 1/2. They want this done by memorization. If you find that you're using a calculator or a table, you don't do that anymore. Memorize. You should be able to say to yourself, oh, sine of what angle is equal to 1/2? Oh, a pi over 6 angle. Well, it can't be pi over 6 because the sine's negative. And so, but pi over 6 would have been positive. Well, what's sine inverse's range? Oh, from minus pi over 2 to pi. Oh, it's minus pi over 6. Again, I can't call it something like 11 pi over 6. It's got to be specifically in this range. So if I start saying things like, oh, Jensen, why minus pi over 6 is right here, which is the same as 11 pi over 6. No, it's not. Not when you're dealing with the number line. Here's 11 pi over 6, way outside of that range of values. And so be careful. It can only be between minus pi over 2 and pi over 2 if it's a sine inverse. Right? And so they're just going to play around with this. This is going to be no different than when they first taught you this in your trigonometry class. Right? What's cosine inverse of negative 1/2? Right? What if we did that? Oh, cosine Inverse of negative 1/2, that is an over 3 angle. Okay, it's got to be, they have to be in the first quadrant, so it's not going to be pi over 3, but it's going to be in the second quadrant, because the range for cosine inverse, right, I'm looking at its range, is from 0 to pi. Oh, that's 2 pi over 3. Only 2 pi over 3 would work for that. 3, tan inverse of negative 1. Okay, so they did do tangent in here as well. I'm not sure why I didn't catch that at first, but they did do some tangent inverses. No problem. I know that the angle I take the tangent of get 1 is a pi over 4 angle. Now tangent is sine over cosine, so it behaves like sine, so it's going to have the same range as sine, from minus pi over 2 to pi over 2, and it's going to be negative pi over 4, and we're finished. They will have us do some problems where they want you just to be familiar with your calculator. These ones right here where they're using the special connections like 1/2, root 3 over 2, negative 1, 0, 1. We want those done by memorization. But they will have things like, this was one I saw in there, tan inverse of root 10 over 9. No problem. Now, they're going to ask for it in radians, so make sure your calculator is in radian mode, but maybe this is really an exercise for you to figure out where your tan inverse button is, and then you just put in the square root of 10 like I'm doing, and then divide that by 9 and close the parenthesis off that was created. And I got a radian measure. I did set my calculator to be in radians of 0.3378896. Awesome. We can then round that accordingly. So they just want us to be familiar with where those buttons are. They're going to get back into ones that we want you to have memorized that you should not use a calculator on. And in fact, the calculator won't give you a response that we like. So what about this? Tan inverse of the tan of 2 pi over 3. Now, what we'd like for you to do is realize that tan inverse and tan undo one another. So this is going to be an over 3 angle. But we have to respect the output of tan inverse. It can't give out 2 pi over 3, so this is the wrong answer. They don't, just cross them out. And that's because tan inverse has a very specific output. Tan inverse is going to take this and give me a pi over 3 angle where it belongs. So what's the range of tan inverse that you learned in your prerequisite course? From negative pi over 2 to pi over 2. Not including those pi over 2's because this is where it's undefined. 6. Sine inverse of the sine of 6 pi over 7. Well, 6 pi over 7 is in what quadrant? Well, that's the second quadrant. Sine inverse can't. So sine of a second quadrant angle is it positive or negative? Well, it's positive. Okay, and so because it's positive, sine inverse is going to go to an over 7 angle where it's positive. Well, that's in the first quadrant. Okay, and that's what I probably should have set up here. I forgot that I didn't say that out loud. Tangent of 2 pi over 3 is tangent of a second quadrant angle, which is negative. Tan inverse of a negative will spit us out in that negative pi over 2 to 0 range. Okay, sine inverse of a positive will spit out in that first region. So let me just follow that up. What's sine inverse of sine of 8 pi over 7? Okay, well, it's going to be an over 7 reference angle. And what's sine of 8 pi over 7? Well, 8 pi over 7 is just in quadrant number 3. Sine in quadrant 3 is negative. Sine inverse of a negative will spit me to that negative region right there. Right? What if I did cosine inverse of the cosine of 6 pi over 7? No problem. It's going to give me an over 7 reference angle. Cosine of 6 pi over 7? Well, that's in the second quadrant. Well, my cosine inverse can spit me out there as I get out 6 pi over 7 straight out. So I'm making these up, right? Cosine inverse of the cosine of, let's do something like this. 13 pi over 7. Now, where's 13 pi over 7? Well, it's just short of 14 pi over 7, which is 2 pi. Right? They're not picking these arbitrarily, just like in your trig class. So that's a fourth quadrant angle. Well, cosine's positive in the fourth quadrant. So cosine inverse is going to be a first quadrant angle that has a over 7 reference angle, pi over 7 reference angle, and so we're going to get a pi over 7. Right, so that's just an extension of that sixth problem there. Awesome. They'll have things like this. Seventh problem, sine of sine inverse of 3/4. Okay, well, that's just going to be 3/4. So if you do it the other way, sine inverse is going to give you some kind of angle whose sine is 3/4. Sine of that angle will be 3/4. And so those just undo each other very naturally there. Then I saw this one too, and I wanted to make sure you saw it. I felt like if I didn't do it, somebody was going to be like, Jensen, you didn't cover that. It's so hard because it looks different than anything else I've ever seen. It's not. Right? What do we have? Cosine inverse of 3x is equal to 2 pi over 3. Okay. And so we want to know, where does that solve? Well, we're just going to take the cosine of both sides. If I want to undo a cosine inverse, I just take the cosine of both sides. So I'll put that in a different color. I'll put cosine of cosine inverse of 3x. Go back to my blue here just to keep things consistent. Is equal to, back to blue, cosine of, and then 2 pi over 3. That's it. So if you want to get rid of a cosine inverse, just apply the cosine. So what do we get out of this? We get a nice 3x on this side because they undo one another perfectly that way. Because remember, it's the cosine. Cosine doesn't have a limited domain or limited range. It's cosine inverse, so I don't even have to think. And cosine of 2 pi over 3, let's think about that. Cosine of 2 pi over 3 is, sine of a pi over 3 angle is root 3 over 2, so cosine is 1/2. It's in the second quadrant, and so it's a positive 1/2 coming out of that. And so what do we get out of this? Oh no, it's not a positive one. I'm sorry, it's a negative 1/2. Cosine is negative in that second quadrant. I'm not sure why I said that. But in that second quadrant, remember, all students take calculus. I'm going to get a negative, and then we're going to divide by 3, so negative 1/6 is our answer. Perfect. That's what we're doing in this section. It should be fun. Should be a nice reminder of all these inverse types of things, which was towards the end of your last class, so somewhat familiar to you.